Hi folks, we're going to take a look at number 2 from the homework. So here it says that Harold wants to build 5 identical pig pens side by side on his farm using 30 meters of fencing. Okay, so I think we're going to assume here that these pig pens are going to be rectangular, and they want us to determine the dimensions that would give his pigs the largest possible area. All right, and they want to calculate the area of this enclosure. That's going to be a maximum. Okay, so the first word I notice is largest. So as soon as I see that, I can identify that this problem is going to involve finding the vertex and then using that vertex to answer the problem. So I know right away what I should be aiming for as I'm doing this problem. Okay, this question is what function are we going to be optimizing? So anything that's geometric, we should be drawing a diagram here. So we've got 5 pig pens. So we got 1, 2, 3, 4, and 5. Okay. And they want the dimensions of the enclosure. So I'll take this whole thing and call it the length, and then this will be the width. All right. And we want to determine the largest possible area. So the function I'm going to be working with is area equals length times width. Now, as with a lot of our problems, we've got 2 variables on the right-hand side. And of course, I can't optimize a function that's got 2 variables. I need to turn this into an equation that has only 1 variable. So this is where I have to use the other piece of information that's given, and that the fact that we have 30 meters of fencing in order to create all these 5 pig pens. So here I got to be careful because that also includes the fencing in between the individual ones. So let's see what exactly this 30 meters entails. Well, I have the base here, L, and the top, which is another L. So I've got 2L, plus I also have to separate out the pig pens along with the ones at the end. So I have 1, 2, 3, 4, 5, 6 lengths that are equal to W. So we have 2L plus 6W. All of these have to be equal to 30. And now I can use this to solve this, what's essentially a system of equations, because I'm going to do a substitution. I'm going to solve one of these variables and then input it into my area formula, giving me a function of 1 variable. So here, I got to see, is there something better to isolate than the other? And I think here what I'm going to do is I'm going to isolate L, because that means I'm going to be dividing 2 into 6 and 30, which divides perfectly, as opposed to if I were isolating W, I'd have to divide 2 by 6. I'd end up being stuck with a fraction. Okay, so 2L is equal to 30 minus 6W. So L is equal, divide this by 2, 15 minus 3W. And now I'm going to substitute this back into my equation. So area is, I'm going to substitute that with 15 minus 3W. And then I'm going to multiply that by W. Okay, and what do I end up with? A quadratic function, because when I multiply this out, I'm going to end up with a W squared. So notice here, I'm not replacing A by 0. I'm not looking for where the area is 0. I'm looking for where this function is going to be at a maximum. So I need to find the vertex. Okay, but if I want to complete the square, I have to first put it in standard form. So W times negative 3W, so negative 3W squared, and then 15W, so plus 15W. Okay, and now I'm just going to follow my procedure, factor out the negative 3. So I'm left with W squared minus, because 15 divided by negative 3 is going to be minus 5W. And now I go through the procedure of completing the square. So W squared minus 2 times 2.5W. And I'm going to add 2.5 squared, subtract 2.5 squared. Okay. So here, the first 3 terms give me my perfect square, W minus 2.5 squared, and then I still have the minus 2.5 squared, which I'm not going to calculate because I'm going to let the calculator do all this for me. So by the way, you might be at the point where you can start skipping a couple of these steps. That's fine, as long as you're not making any mistakes. So here we have negative 3 times the first expression, W minus 2.5 squared, and now I'm going to multiply these 2 expressions. Okay, do that with the calculator. So here we've got, I know that's going to be positive because I'm multiplying 2 negatives. So 3 times 2.5 squared is equal to 18.75. So plus 18.75. Okay, so now that I have it in vertex form, I'm going to see about answering the question that's being asked. So I go back and I see what are they looking for? Well, they're looking for the dimensions. Well, I know that in order to get my maximum area, the width has to be equal to 2.5. So I have the width with 2.5 meters. So now I can just stick that into my equation for L to find the length. So 15 minus 3 times 2.5. So here, 3 times 2.5 is just 7.5. So 15 minus 7.5 is 7.5. So here are my dimensions. And if I'm looking for my maximum area, that's going to be the y value of the vertex. Since the y value in this function is area, y value of the vertex is just 18.75. And since we're talking about area, it's meters squared. Okay, so just to give a quick recap. First of all, recognize that this is going to be a vertex problem because I'm looking for an optimal value. In this case here, a largest value. Step number 2, get myself a diagram and decide the function that I'm going to optimize. And as in many cases, we have to use another piece of information that's going to allow us to do a substitution so that I get a function in terms of only one variable. Okay, that's it for this one.